Hi, I'm Wanrong from Harvard University. Our paper is about attribute privacy, framework and mechanisms. This is joint work with Olga Ohrimenko. She's at the University of Melbourne, and Rachel Cummings. She's at Columbia University. Attribute privacy protects the global properties of sensitive attributes in the dataset from making during analysis. For those of you who are familiar with differential privacy, we're used to thinking about privacy at the individual level, corresponding to rows of a database. And we ask questions of the form. We can inversely learn about Alice data based on an analysis of this dataset. In this work, we instead consider privacy of the attributes. That is, we take the view of a database owner who wishes to publish aggregate statistics about her database, and must also protect privacy of aggregate information in certain sensitive columns. In this example, the owner may wish to publish the average SAT score of its students, but we know that SAT scores are correlated with sensitive attributes such as race, gender, and parents' income. So even though the SAT score is not sensitive, privacy protection is still needed to protect those other attributes. Here are a few use cases for attribute privacy. For example, hospitals may want to share the number of COVID cases with federal health agencies, but want to protect their mortality rate because that will affect their funding, their future funding opportunities. And companies want to share client data, but want to protect proprietary information. And researchers provide data for reproducibility in the peer review process, but don't want other researchers to perform new analysis in the dataset. In general, attribute privacy is to share aggregate statistics of a dataset, but want to protect other aggregate statistics which may be correlated with the shared information. We introduced two notions of attribute privacy in this paper. The first one is dataset attribute privacy, which protects the properties of a particular dataset. For example, we want to protect demographic information in training sets for machine learned facial recognition model. And our second privacy notion is the distributional attribute privacy, which protects the parameters of the underlying distribution from which the dataset was sampled. For example, a pharmaceutical company running medical trials for a new drug is interested in the distribution of outcomes on the general population, not just the individuals selected for this trial. And in this paper, we propose definitions for capturing the two attribute privacy by instantiating a general privacy framework called the pufferfish framework. We also give three mechanisms to achieve attribute privacy. We propose the attribute private Gaussian mechanism that satisfies dataset attribute privacy. And we have the attribute private Markov field mechanism that satisfies the distributional attribute privacy. And there's a general mechanism for the pufferfish framework, so it can also be applied here, the Wasserstein mechanism. And for more information, please check our paper online. Thank you.